Welcome everyone to the day 26, and now it is the time for the inbuilt support of data structures in the language of Java. And we go and call it as collection frameworks. In this video, we'll get introduced to the collection frameworks, what the collections are, how do we go and store data when you have more than one piece of data to store in the different ways. So we're going to talk about the collection framework. We get started with something called as list, array list, and I say to go and deep dive the similar data structures in this video. So if we go and talk about the collection itself, you can see the screen here, correct? Now if you see here in this case, everything which you see in white, you can consider them as an interface. They are the interface. And everything which you see in yellow, you can think of more of like they are classes. So if I go and talk about the collection framework, and most of these codes are lying in the package called java.util.start package inside this. This is a hierarchy of collection framework. What that means is, at the top I have something called iterable. Then I have a collection interface. Then all these list, queue, and the set, they kind of go and further implement these interfaces. So these are the interfaces, and these are the concrete implementation of these interfaces. We're going to talk about some of these in details in this video. But before we move further, let's try to first of all go and talk about that what itself is a collection. What is the meaning of the collection? Collection basically means that you are able to go and store more than one items with all the things that we have already learned so far. Can you guys tell me which data type that we have talked so far in the world of the Java which can go and store more than one item in itself? Yes, you're right. We have talked about a data type called as arrays. But the array has its own limitation. Do you remember how do we go and instantiate an array? We have seen that to instantiate an array, we can simply go and say that int arr equals to new int 5. As in when we go and implement or initialize a new array, in the very beginning itself, I have to go and say that, boss, what is the size? It can only go and store 5 elements. Now, the challenge with defining array and using it in this form is that once your size is decided, let's say that at the run, I want to go and store something like, say, like 6 elements, I will not be allowed to. If I go and try to add element more than its allowed index, it will go and tell me that index not allowed exception, stack overflow exception, these kind of errors that will come out. So in order to solve this problem, how can I go and solve it? I would like to solve a problem by having a dynamic size array. So normally people have to go and solve the problem yourself, and later on in the data structure we will see that. Let's say that if I have an array 1 and this is of the size, for example, 10. So normally the approach which people feel is that as soon as you reach, say for example, you have filled 80% of the size, it means that 8 out of 10 spaces are filled. So normally what we did, we normally go and try to define an array 2, which is 2 times the size of array 1, and then copy array 1 data to array 2 data. What do you do? We first of all go and define the array 2, which is twice the size of the array 1, and then take out all the data from the array 1 and put the data into the array 2. That's what we do. And then again, when this process continues, when you again reach the 80% of array 2 capacity, you again have to go and double the size. This is how normally if you have to go and define a dynamic array, this is how we go and do the implementation. Java has done this work already for us. It has already implemented this kind of a behavior, and the data structure which they have exposed to us, which we can go and make use of, that is called as a array list data structure. That is called as a array list data structure. So array list is a Java reply that, okay, you want to make use of array type of data structure, okay, go ahead, but you now don't have to worry about the size. Let me go and open my Eclipse and let's try to understand this with the help of a code example itself. So let me go and open my Eclipse, let's get started. In this, let me go and define a class. Let me go and call this dot the project. It has to be a Java class. So I go and say that Java class. And let me go and call this as, what should I call the name? Let me go and call it as an application. Perfect. And I would like to have a public static void main method. So I go and select it so that I don't have to type it again. Let me increase the font a little and minimize this. So this is my application. Now we have just talked about the array list. So let me go and define the array list. So I go and call it as array list al equals to new array list, like this. Now as soon as I go and do this, you will see there's a yellow warning which is coming up. If I go and open my scribble, you will see there's a yellow warning which is coming up warning. It is coming because normally Java has a very strongly typed language where everything we go and define, we go and say that what type it is. For example, previously when I was going and saying that I have to go and store an array like this, I'm going to say what type it is. But when I've defined this collection called as an array list, I have not defined what kind of data I'm holding. But Java allows us. In the previous versions of the Java, it allowed me to do this. So let's keep the things as it is and we'll see that what are the challenges that we face with this and how do we overcome it. So I've defined this array list AL, and now what I can do is that and this I can go. So by default, when it is beginning, by default the size. So internally this array list also make use of the array. And the beginning, the size of this will be equals to 10. As you reaches the size, typically it will always try to double 10 to 20, 20 to 40, 40 to 80, and like that the size grows. Now I'm here. At this point, I want to go and add something. Say for example, array list dot add, and I can say that. Now if you see here, this method definition dot add. Right? If you see here, it's showing object. It's expecting object. Since object is a parent class, I can go and store anything in this. I can go and store a number, for example, 5. It allows me. I can go and store a string called as Vishwa. It will allow me. I go and store a boolean called as true, and it will allow me. So if you see here, all of these lines is in yellow, giving me a warning, but it allows me to store different types of data. So this is how you also go and insert. So one of the ways of inserting data into a list is that this add method is used for inserting the data. So I'm able to insert the data with the help of the add method to this array list. Perfect. Now how do I go and retrieve it? To add the data, I have an add method. To retrieve the data, I have a method called as a get. And in that, I'll have to go and provide the index. So for example, in this case, if I have to go and read the value at the 0th index, what I'll have to do is, I'll have to go and say that al minus get me the value at the 0th index. Now I stored what? I stored at the 0th index 5. So I'd like to go and store this data here. So I'll go and say that end number equals to al dot get 0. But what I see here is the compilation error. What is the error which is coming up? If I go and click on this red button, it is saying that add the cast to the end. Add the cast to the end. Why is the error? If I go and click on this declaration, right, you can see this get method is returning E. What you see here is something called as a generics. By default, right, if I come here in this application class, this is returning something called as an object right now. And here I have int. So I have to, if I have to make it work, I'll have to cast it with the int. So what I go and do is that, how do I do the casting? I go and write int in the top of it, indicating that whatever this is, whatever that you are seeing right now, this is casted within, so it has to be converted to an integer. Similarly, if I have to go and do this for the second element, right? If I go and write string name equals to al dot get 1, again I'll get an error here, a compilation. So I'll have to what do? I'll have to go and cast it with something called as a string. So for different types of the data, I always have to be on the top, that I should know that at what index what data type is there, so that I can accordingly go and cast them. Now what you see here is error prone. And Java Maker actually realized that, dude, this has to be fixed. And that's how, because Java is a strongly typed language, everywhere we should know that what variable or at what line of code refers to which data type. They brought a concept called as a generics. What that means that every time we go and define a collection framework, we should go and tell a type. So for example, if I go and change this, and I'm defining this array list, I should go and say that what type it is, right? So instead of defining this, I can go, let me go and comment all of this. I should normally go and say that array list, and if I have to go and store the integer, let me go and say that int array list equals to new array list. Now when I go and do this, again I get error. I'm going to provide the type called as an int here, but this is not allowing me to accept that. This is because this int which you see is a primitive. Anything and everything in the world of the collection framework, they always deal with the objects classes. So int will not work. In order to solve this problem, Java came up with the concept called as the wrapper classes. So wrapper classes are basically used for the object representation of the primitives. For example, I have int. So int have a wrapper class which refers to the integer. For example, I have short. Short has a wrapper class called as capital H, short. I have something called as a long. Long has a primitive class capital Long, long. So whenever you have to go and make use of the primitive, make sure that you're making the corresponding wrapper classes of those primitives to be used in the collection framework. So if I have to go and store the integer, what and how do I write? I'll have to go and write something like this. Integer. And now I can do the same exercise. I can very freely say that al.add 5, it will allow me to do it. If I go and say that al.add -11, it will allow me to do it. But the moment I want to go and add something called as al equals to true, this will throw me a compilation error. Why it is throwing me the compilation error? Because it's saying that, boss, this array list has a data type of integer. What you're trying to store is, boss, a boolean value, which is not allowed. So I will have to remove this. This will not work. I can go and say that al.add, and I can go and set a value. Let me try and put something called as Vishwa. Again, this will not be allowed because this is an integer. At the compiled itself, I'm able to understand that this is via string, and this can only expect an integral value, so this is not allowed, right? So when you go and properly provide the type of the data, this works well. Fair enough? Cool. So I have to make sure that I'm not using the wrong data types. And now once I have done it, when I'm trying to retrieve al.get 0, I can safely go and store that in a variable of a type. Let's say that int data equals to al.get 0. In this, I can safely get the data, because since the data type of the al is integer itself, so I'm safely getting this value as integer. And since I've defined this primitive, this integer automatically gets converted into the int, a primitive. This is also called as a unboxing. Unboxing. This behavior is also called as unboxing. Fair enough? Am I clear? Does it make sense? Also, if you see here, in this case, when I'm trying to add the 5 is a primitive, minus 11 is primitive. When I go and add it, but it takes integer. So this int internally is getting converted into the integer. Java is taking care of this. This phenomena is called as a auto boxing. So when the int gets converted into the integer, or in other words, if the primitive gets converted into that wrapper classes automatically, this phenomena is called as auto boxing. And when you come back from the wrapper class to the primitive, this phenomena is called as unboxing. This phenomenon is called as unboxing. So this is auto boxing and this is my unboxing. Fair enough. And now in this case, I don't have to do any kind of typecasting because I already know that, okay, I'll be getting the integers only. Fair enough. Just like array list, no, the array list, the challenges of array list is similar. And the challenge of array list is that it's same as of array. So array list makes sense in the situations when you have to make a quick reads, right? Because it is index based. But it's a challenge when you have a dynamic set of data, because every time, even though it looks like you can add as many data as you want, but internally it's making use of array itself, which has a fixed size. And every time you breach that size, it have to go and double its capacity, which is a time taking and expensive process. So whenever you feel that you have a dynamic size and the changes, the number of items that you need to go and store is very variable, it can change. Typically in those kind of situations, a better than array list, a new type of a data structure is quite helpful, which is called as a linked list. Let me do a quick, the representation how the linked list looks like. Right. So if I go and talk about the linked list, so unlike the array, the linked list comprises of the linked list node. So I have a node called as 1. Then I have a node called as 2, something like this, 5, 9, 10. So every node has something called as the data. For example, this node has 1 as the data. This is 2 is the data in this node. This 10 is the data in this node. So every node has a data, and every node also knows the address of the next node. So 1 knows the address of the 2, 2 knows the address of 5, 5 knows the address of 9, and 9 knows the address of 10. So every node knows the address of another. So every node that I have will have two type of information, data, and number 2 is the address of next node. The starting node is normally by convention called as the head, and the last node by convention is called as the tail. So when you go and store the data in this form, this is called as a linked list data structure. We're going to talk in detail in the coming days when you go and actually define the linked list on our own. We do the operations on that. We'll go and talk a lot about this in the linked list in the coming days. But for now, for your understanding, this is a linked list, my dear friends. 1 is the head, 10 is the tail, and this is how the linked list data structure looks. And the beauty of the linked list is, one of the two main challenges of the array. First, array has a fixed size. That's one big challenge. The another challenge with the array is that it cannot survive in the fragmented memory. What that means that whenever I go and define an array, say for example, int a equals to new int 5. Array as a requirement, they need that if they have to go and store their element, the element has to be stored in the contiguous location. What that means that, let's say that this is my memory space and 0 indicates the empty space and cross indicates the occupied space. Fair enough. Now I know that, let's say that I have to go and store 5 elements here. I have enough space level 1, 2, 3, 4, 5, 6, 7, 8. But there is no contiguous 5 locations. So there is no contiguous 5 location. This can't be stored, and it will go and throw me the out of memory expression. So in the case of the fragmented space, when you don't have enough contiguous memory space already left, and if you go and define a larger array, and if you don't find the space, even though you have the fragmented space, array cannot be used there. So because of these two challenges, another data structure which comes handy is called as a linked list. Linked list says that, boss, I don't care how many data you want to it. The more you want to it, I'll keep on adding it. So that's the first advantage. It goes and solve the first fixed size problem. And secondly, it says that, dude, I'm like a snake. I can take the first element here, then I can take the second element here, then I can take the third element here, fourth here, fifth here, sixth here. So like this, I can go and cover the entire segmented space. I don't care. If it is fragmented, that's okay. I only need to know the address of the next node, and the next node should be only care about the next node. And these nodes could be separated apart, and I don't care. And that's the whole advantage of linked list. How do we go and define the linked list data structure? Let's try to go and see that also. So linked list definition is very similar to the array list. So if I go to my Eclipse, and let me go and comment this out. So what I do is, I go and call it as linked list, li equals to new linked list. As you can see, it is coming as the Java utils package itself, and again I'll have to go and provide the type. So linked list should be, for example, string, and this also I can go and call it as string. And then inside this linked list, I can go and add the values. For example, li dot add. If you see the add, if I go and open my scribble, right? If you go and see this add method, there are multiple add methods, right? You can go and add the string. You can go and add the string at the given index. Right. So I can simply go and provide the index here. For example, instead of Vishwa. So by default, it will go and set the value at the 0th index. Then it will go and do the li dot add Mohan. It will go and add the element at the second index typically, right? And then if I have to go and get it, I can simply go and say that sys out, and I'll go and say that li dot get, and then again you get the index first list. So if I go to get the head, I should go and pass the get 0. If I go and run this, it is printing Vishwa. Instead of letting get 0, I can also call it as a get first. So what I go and do is get first. So let's try and run this, and it's printing correctly. Fair enough. So this is how we go and define a linked list. Perfect. So now since we have seen that two of the data structures which Java provides the implementation, array list and the linked list. Sometime back when you were seeing this diagram I was showing you previously, you saw that both this array list, right? If I go and talk about both this array list and this linked list, they have the same parent, which is list. So basically array list and linked list, this is not linked, this should be linked list, is the concrete implementation of this interface called as list. So when I'm writing this code here, sir, right, Eclipse, I can actually go and call this not as the linked list, but I can simply call it as the list itself, and it should work perfectly fine. The only thing is that I'll have to go and import the list. So I'll have to go and say that import java.util.list. Similarly, if I have to go and define something called as a array list, I can simply still go and call it as integer, and I go and call it as array list equals to new array list. Fair enough. Now can you guys tell me which principle of Java does it satisfy, which object-oriented principle? So typically this is trying to behave more of like a runtime polymorphism. In Java, it's always a good practice that you should always code for the interface. So this list is an interface, this list is an interface, and then have the concrete implementation of array list and the linked list. Fair enough. So now let's try to see that how we can go and iterate over either the array list or the linked list. So the next thing that we need to understand is that how do we go and iterate over the array list and the linked list. So let me go and comment this portion of the code. Go back and let me go and write the code here itself. So what I do is, let me go and define a list of integer, and let me go and call it as my list equals to new array list. By default, if you don't provide the size of this array list, it will be 10. And if you want, you can yourself go and define the initial size. Let's say that I want to go and have an initial size of say like 12, I can still do it. Fair enough. So this is how I'm going to find the array list. We go and add a few items into this. So I go and say that my list dot add 73. Let me go and copy this all and paste it multiple times. Right? And let me go and provide the values. For example, values 12, 99, 143, 21, 46. Now, since I have a multiple data entries added into this list, if I want to go through each of these lists, I will have to go through them one by one. How do we do it? There are two ways of doing it. And this whole process of going through all the items of a collection, just like for example here array list, that is called as iteration. That is called as an iteration. So whenever you use or hear this term called as iteration, it means that I want to go to each item one after another. I'm just trying to go to the each item one after the another. So what I go and do here is that let me go and write a for loop. So let me go and write for int I equals to 0, I is less than my list dot size. So size method gets you the what is the size of the given array list, and then I plus plus. So this is a conventional way of writing the for loop, which we have been already aware of. And here I can go and write this as out, and I go and call it as my list dot get, and you want to provide the index here. If we go and run this code as now, we'll see that all the numbers will get printed one after the other: 73, 12, 19, 134, 21, 46. So this is one of the way of writing this for loop, right? This is one of the way of writing this for loop. What I can do is that there's another smarter way of writing this for loop, which is called as for each loop. How do we write? We're going to call it as for, and here we're going to put this integer, and I'm going to call it the num, followed by the my list. And how I'm able to do it? So every collection which is somewhere related to this iterable interface, if you go and see here, this array list is a child of list, list is a child of collection, collection is a child of iterable. So every data structure which is somehow related in the hierarchy of the iterable you should be able to go and run this for each loop. And so I come back to this for each loop, and now here I can simply go and print this now. If I go and run this, 73, 12, 19, 134, 21, 46. Fair enough. I can run the similar code for an linked list as well. I just have to go and copy this. So let me go and define another linked list below this. And let me just go and comment this out. Right? I just have to go and call, instead of array list, I'll have to go and call it as linked list. Everything remains same. Now in the case of the linked list, I cannot have to provide the size, so I'll actually go and remove it. And now if I go and run this, actually the outcome should not be impacted. Run as 73, 12, 99, 134, 21, 46. Fair enough. So we have so far seen that we have been able to define the array list, we have been able to define the linked list. Both have the similar characteristics, both are maintaining the order in which the element is being inserted. Array list makes the read operation much faster. Linked list is more flexible when you have a dynamic sizing. Fair. Now let's try to talk about that. How do we go and add a value to this? So these are all the user defined data types. What if my requirement is that I want to go and make use of a user defined object has to be added in a array list or a linked list? We can still do it, right? How can I do it? Let me go and comment all this code. Fair enough. So what I'm going to do is that let me go and define a class. Let me call this class as class and something, for example, vehicle. Now this vehicle will have private string name, private string color, and something called as private int price. Now based on that, what I go and do now is that I'll go and right click and I'll try to go and provide the constructor using the fields. So this, I'll go and generate a constructor. I would also want that since the fields are private, there should be a getters and setters for this. So I go and go to the source again and click on generate getters and setters. So I'll go and select all of these and click on the generate. Not only that, I would also want that when I'm printing this object, instead of printing gibberish, it should print some sensible sentences in English. For that, I'll have to go and override the toString method. Here again, Eclipse comes handy, so I can go to the source and try to click on the toString method. So we'll go and generate the toString method. Fair enough. So now if I go and define a list, and let me go and call it as, this list has type called as vehicle, and then my call is a vehicles equals to new array list. I can actually go and put these vehicles inside that. So I can go and say that vehicle 1 equals to new vehicle, and then it will have a name. Let me go and call it as I-20. Color is red, and the price is somewhere around 7 lakh. Similarly, let me go and put few more vehicles. Vehicle V2, vehicle V3. Let me go and call it as scooter. Scooter color is gray, and the price is 1 lakh. Vehicle 3 is BMW. The color is black, and the price is, say for example, 70 lakhs. So now what I can do, I can go and add these vehicles V1, V2, V3 inside this the same way, right? So I go and say the vehicles dot add, and I go and call it as V1. I copy this, and I keep on adding this V1, V2, and V3. V1, this is V2, this is V3. Right? So I've added these vehicles V1, V2, and V3 inside this list. And this is how you can do the similar thing for the linked list also. Now if I have to go and iterate over it, I can again go and write the same thing for, and I'll go and say that vehicle V equals to vehicles. And then I can just go this out, and I will pass this. So if I go and run this now, I'll have a more meaningful representation of all these vehicles. You can see it here. In the case if I just go and comment this method and run this code again, we'll find that all these objects hash codes are getting printed, which doesn't make much sense to us, right? So the toString method is very important if you want to make sure that the meaning or the representation is perfectly fine. Fair enough. So let me go and remove all of these. So if I go and run this again. Similarly, you have to go and create your own custom object and add it into the linked list. Everything should work accordingly. So finally, we are done with the day number 26. We are hardly left with 4 more days. Today, we got started with collection frameworks, which again is a very important topic in terms of your development, in terms of DSA, and also in terms of the interviewer's favorite topic to ask questions from. Make sure that you're doing these topics well. Today, we talked about collection framework, got started, what collection is, and we also talked about the list and its traversal methods. Stay tuned for the next video, which will be on the day 27, where we go and deep dive collection framework more. I'll see you more there.